Hello everyone, welcome to the Tech Think Tank and I am your host Saptashi. In today's video, we're going to be talking about one of the most popular and powerful tools in the world of software development, Docker. Docker has revolutionized the way we build, deploy, and manage applications, and has become an essential part of modern DevOps workflows. Whether you're a developer, system administrator, or IT manager, understanding Docker is essential for staying competitive in today's fast-paced technology landscape.
This is the agenda of today's video. We will discuss all these topics in detail. So please stick to the end of the video to learn about them. Let us start with knowing what a Docker is.
Docker is a popular platform for containerization, which is a method of packaging an application and its dependencies into a single unit called a container. Docker allows developers to create, deploy, and run applications in a containerized environment, providing an isolated and consistent environment for application development and deployment across different machines and operating systems.
Docker containers are lightweight, portable, and can run on any machine that has the Docker runtime installed. They allow developers to package their applications and dependencies together, so they can be easily moved from one environment to another without worrying about compatibility issues. Docker also provides a wide range of tools and services to manage containerized applications, such as Docker Compose, Docker Swarm, and Docker Hub. These tools help developers automate the deployment, scaling, and management of containerized applications. Now let's have a look into Docker Compose and see how it works in real world.
Docker Compose is a tool that allows developers to define and run multi-container Docker applications. It uses a YAML file to define the services, networks, and volumes required for an application, and then uses that file to create and manage the containers. Here's how Docker Compose works.
1. Define your application services. In a YAML file, define each service in your application as a container, along with its dependencies, environment variables, and ports to expose.
2. Define networks and volumes. You can define custom networks and volumes for your application, which allow containers to communicate and share data between each other.
3. Run the application. Once you've defined your services, networks, and volumes, you can use the Docker Compose command to start and run the entire application with a single command.
4. Manage the application. Docker Compose allows you to scale your application services up or down, stop and start the containers, and even upgrade the application by changing the configuration in the YAML file.
Docker Compose is particularly useful for development and testing environments, where you may need to run multiple containers to simulate a complex production environment. It simplifies the process of managing multiple containers, and makes it easy to start and stop your entire application with a single command.
It's time to learn about Docker Swarm and its working method. There is a lot more to come, so stay tuned.
Docker Swarm is a tool for clustering and orchestrating Docker containers. It allows developers to create and manage a swarm of Docker nodes, which can host and run containerized applications across a cluster of machines. Here's how Docker Swarm works.
1. Initialize the swarm. A single Docker node is designated as the swarm manager, and it is responsible for managing the other nodes in the cluster.
2. Join nodes to the swarm. Other Docker nodes can join the swarm by running a command and providing a token generated by the swarm manager.
3. Deploy services. Developers can define their applications as Docker services, which consist of one or more containers running the same image. Services can be scaled up or down to meet demand.
4. Manage the swarm. Docker Swarm provides tools for managing the cluster, including rolling updates, scaling services up or down, and managing secrets and configurations.
5. Load balance traffic. Docker Swarm also includes an internal load balancer which automatically distributes traffic between containers running the same service.
Docker Swarm is designed to be highly available and fault-tolerant, with multiple nodes able to take over the responsibilities of the swarm manager in case of a failure. It provides a simple way to manage and orchestrate Docker containers across a cluster of machines, making it easier to deploy and scale containerized applications.
Wow! That was a great explanation about Docker Swarm and its working methods. Now let's deep dive into the world of Docker Hub.
Docker Hub is a cloud-based registry for storing and sharing Docker images. It provides a central repository for developers to store and distribute their Docker images, making it easy to share containerized applications with others. Here's how Docker Hub works.
1. Build and tag images. Developers build their Docker images and tag them with a unique identifier, such as a version number or a Git commit ID.
2. Push images to Docker Hub. Developers push their images to Docker Hub using the Docker CLI, which uploads the images to the Docker Hub registry.
3. Pull images from Docker Hub. Other developers can then pull the images from Docker Hub to use in their own projects, either by running the docker pull command or by specifying the image in a Docker file.
4. Automate builds. Docker Hub also provides a feature called Automated Builds, which allows developers to link their Docker Hub account to a Git repository and automatically build and push Docker images when changes are made to the code.
Docker Hub also includes features for managing access to Docker images, including private repositories for storing images that are not meant to be publicly accessible. Developers can also use Docker Hub to discover and share pre-built Docker images for common software packages, such as databases or web servers.
Hope you are still with us. It's time to know how we can implement Docker in our project.
There are several ways to implement Docker in a project. Here are some common approaches. 1. Containerize the application. The most basic approach is to containerize the application itself. This involves creating a Docker file that defines the application's environment and dependencies, and building a Docker image from that file. The resulting image can then be run as a container on any machine that has Docker installed. 2. Containerize dependencies. In some cases, it may make more sense to containerize only the application's dependencies, rather than the application itself. For example, if the application relies on a particular version of a database or web server, you can create a Docker image for that dependency and use it as a base image for the application's image. 3. Use Docker Compose for multi-container applications. If your application consists of multiple containers, you can use Docker Compose to define and manage the containers as a single application. Docker Compose allows you to define the services, networks, and volumes required for the application, and then start and manage the entire application with a single command. 4. Use Docker Swarm for container orchestration. If you need to manage a cluster of Docker nodes, you can use Docker Swarm to orchestrate the containers across the cluster. Docker Swarm provides features for scaling containers, rolling updates, and managing network and storage resources. 5. Use a container management platform. There are also third-party container management platforms, such as Kubernetes or OpenShift, that can be used to deploy and manage Docker containers at scale. These platforms provide more advanced features for container orchestration, load balancing, and automated scaling.
All great things have some not-so-good things about them. Let us discuss them here. Let's see the pros and cons of Docker.
Let's talk about the advantages first. 1. Portability. Docker containers can run on any machine with Docker installed, making them highly portable and allowing developers to easily move applications between development, testing, and production environments. 2. Isolation. Docker containers provide a high degree of isolation between applications and their dependencies, reducing conflicts and making it easier to manage dependencies. 3. Scalability. Docker containers can be easily scaled up or down to meet demand, allowing applications to handle increased traffic or workload without requiring significant changes to the underlying infrastructure. 4. Efficiency. Docker containers use fewer system resources than traditional virtual machines, allowing more containers to be run on a single host. 5. Consistency. Docker images provide a consistent environment for applications to run in, reducing the risk of errors or bugs caused by differences in operating system or dependencies.
With these advantages, Docker brings some disadvantages too. Let's know about them now. 1. Complexity. Docker introduces additional complexity to application deployment and management, requiring developers to learn new tools and workflows. 2. Security. Docker containers share the host operating system kernel, which can introduce security risks if containers are not properly secured and isolated from each other. 3. Performance. While Docker containers are generally more efficient than traditional virtual machines, they can still introduce some performance overhead due to the additional layer of abstraction. 4. Learning curve. Adopting Docker can require a significant learning curve for developers who are not familiar with containerization concepts and tools. 5. Debugging. Debugging issues in a Docker container can be more difficult than debugging issues on a traditional server, as containers are ephemeral and can be recreated or destroyed at any time.
Do you know when to use Docker and when not? After watching this next part, you will have a clear picture of when to use a Docker and when to avoid it.
Best places to use Docker. 1. Microservices architecture. Docker is particularly well suited for applications built using a microservices architecture, where each component of the application is containerized and can be scaled independently. If you want to know more about microservices, click the pop-up banner now or the link in the description for a detailed microservices architecture video.
2. DevOps workflows. Docker can help streamline the development and deployment process, making it easier to build, test, and deploy applications across different environments.
3. Multi-platform development. Docker makes it easy to develop and test applications across multiple platforms, as containers can run on any machine with Docker installed.
4. Rapid prototyping. Docker can be used to quickly create and test new applications or features, as containers can be spun up and torn down quickly and easily.
Let us discuss where not to use Docker.
1. Small and simple applications. For small and simple applications, Docker may introduce unnecessary complexity and overhead.
2. Legacy applications. Legacy applications that were not designed with containerization in mind may be difficult to containerize, and may not benefit from the portability and scalability of Docker.
3. Resource-constrained environments. Docker containers require additional resources, including memory and CPU, which may be a concern in resource-constrained environments.
4. Security-critical applications. Docker can introduce security risks if containers are not properly secured and isolated from each other. In some cases, it may be more appropriate to use a traditional virtual machine or bare metal server for security-critical applications.
Coming up next is a very interesting, and probably one of the most talked about debates. Is Docker better or Kubernetes? Let's solve the puzzle here.
Docker and Kubernetes are two different technologies that serve different purposes and that are often used together. Docker is a containerization platform that allows developers to create and run containers on their local machine or in the cloud. Kubernetes, on the other hand, is a container orchestration platform that automates the deployment, scaling, and management of containers in a cluster.
The main differences between Docker and Kubernetes are: 1. Function. Docker is a containerization platform that focuses on creating and running containers. Kubernetes, on the other hand, is a container orchestration platform that automates the deployment, scaling, and management of containers in a cluster.
2. Scale. Docker is generally used for smaller deployments, such as single-host or small-scale multi-host environments. Kubernetes, on the other hand, is designed to manage large-scale container deployments across multiple hosts.
3. Complexity. Docker is relatively simple to use, with a minimal learning curve for developers. Kubernetes, on the other hand, is more complex and requires a deeper understanding of container orchestration concepts and tools.
4. Features. Kubernetes provides a wide range of features, including container orchestration, automated scaling, self-healing, and service discovery. Docker provides a more basic set of features, focused primarily on containerization.
Which one is better depends on your specific needs and use case. Docker is best for containerizing applications and deploying them quickly and efficiently. Kubernetes is best for managing clusters of containers and ensuring that applications are always available and running at the desired scale. If you have a large, complex application with multiple components, Kubernetes may be a better choice. If you have a simpler application, Docker may be all you need.
Ultimately, the choice between Docker and Kubernetes depends on your specific requirements and the complexity of your application. Docker and Kubernetes are two different tools that serve different purposes, so it's not a matter of one being better than the other. It's also worth noting that both technologies have a steep learning curve, so it's important to invest in proper training and education before adopting either technology.
If you want to learn more about Kubernetes, click the pop-up banner now, or the link in the description for a deep dive introduction to container orchestration.
So that's it for our video on Docker. We hope you found it informative and helpful in understanding how Docker can help you deploy your applications more efficiently. If you have any questions or comments, feel free to leave them in the comments section below. And if you enjoyed this video, be sure to like and subscribe to the Tech Think Tank for more content on technology, programming, and everything in between. Thanks for watching, and we'll see you in the next video. Until next time, keep on learning and exploring.